Can you just click? I think some of you might have seen this. Can you just click, put the cursor on the top and click anywhere? This is the launch of a project called Skyroot, and it was shown live on TV. The name of the company is Skyroot. And what did they do? For the first ever time, a private small satellite company called Skyroot launched, and it was shown live on TV. And it was just once again started with 3-4 young students, Funny and others, in the age group of 21 to 26 in Hyderabad. And you can see here, Dr. Pawan Goenka, Jitendra Singh, the minister, and Dr. Kiran Kumar, I understand he was there in JSS campus 2 days ago. All these people applauded the greatness of this particular achievement. And once again, in this case, they made a significant usage of additive manufacturing to make the parts. Okay. So, and that is, ISRO chairman, everybody can recognize it now. So, if you go to any labs like ISRO or DRDO, Agnikul or Skyroot, you see young engineering students from different branches collaborating together and making wonderful engineering objects, from starting from rocket engines to medical devices, and successfully using because of the power of digitization connected with the design and manufacturing. This is my own personal experience. Okay. What you see on the left side is a flapping mechanism. What is a flapping mechanism? If you have seen the movie called Yuri, Vicky Kaushik's movie, you saw many those ornithopters, which are bird mimicking mechanical birds. How do they fly like birds? Because they are able to convert the rotary motion from the motor into the flapping motion of the wings. So the heart of this particular mechanism or mechanical bird is a small mechanism which converts the rotary motion into the flapping motion. So it's nothing but a small gearbox. So the gearbox is what you see on the left side, and I got it 3D printed. I actually conducted more than 10,000 people have conducted workshops. I'm talking about way back in 2000 to 2005. Just click on the bottom portion. This is from Jain University campus in Bangalore. You can see here how an ornithopter is flown with an RC unit, and that a particular ornithopter has got a small camera which is able to continuously grab the images from the ground and transmit it to the mechanical engineering or aeronautical lab. And the duration of this particular thing is about 7 minutes. And the beautiful thing is the mechanical bird just weighs less than 150 grams, and the mechanism that you see here is called flapping mechanism that weighs less than 10 grams. And how was it done? Once again, it was done with a small 50,000 rupee 3D printer, which you have got access to in the IDEA labs. So, with these examples, can you just move to the next one?
What
Polymer, ABS. Next slide. So, you can see here, the fundamental principle to this is something which even an 8th standard student can understand. How do I convert rotary motion into flapping motion? Top left. It is called slider crank mechanism. Sometimes, I think you might have taught this mechanism suggest some places. So, with 150 rupees, you can make a bunch of 3 students to make an ornithopter. The only thing which they may not have is the gearbox. If you don't have the gearbox, you can make use of a crank rod and elastic rubber. So if you have got it, if you don't have the gearbox, you can still do the experimentation with the matchstick and the rubber. Okay. So why is this important? This is important because most of the time students get disconnected with the subject because they never get a chance to convert their theoretical insights into practical things. So I would like to tell all the faculty members who have assembled here and the student representatives who are here, if you are able to convert the classrooms into active learning sessions, then the kind of outcomes that you get will be tremendously powerful. If you are talking about Industry 4.0, 3D printing, additive manufacturing, it's no longer a lab like this. You'll be surprised to know that there are 10,000 schools in the country today which have got Atal Tinkering Lab. What does it mean? It means a student who is passing out of 6th standard is able to design and 3D print a part before he passes 8th standard. So you just put your hand on your heart and start thinking. If a student who is part of the 4th standard, 5th standard, 6th standard, 7th standard, 8th standard is able to design a part using a free app called Google Design and print a part and use a part for demonstrating physics, chemistry, mathematics concept while they are in the elementary schools, what should be the level of achievement for an engineering student? You just start thinking about it. So there are 10,000 schools in the country today which have got adult tinkering labs, which are teaching the CAD, IoT practices, 3D printing practices in the 4th standard. Now, if you go to the real world, I'm talking about Tata Motors in Pune, I'm talking about TVS in Hosur, I'm talking about Ashok Leyland or Wipro, Bangalore or Chennai. You see IoT 4.0, Industry 4.0 enabled, a cyber physical system enabled labs of this kind. If you are under the impression that the manufacturing facilities of the current generation companies have got lathe machines, drilling machines, NC machines, like in the world, full of chips, full of dirt, full of grease, completely you are mistaken. If you go to the companies like Apple Electronics, if you go to the companies like Tata Electronics, if you go to the companies like Ather and Ola, which are there near Hosur, in the outskirts of Bangalore, you will see plants of this kind. The manufacturing plants there look like software companies. You just see, am I talking here? Absolutely not. Look at a 3D printed post office in Bangalore, and a additive manufactured bridge in Holland. In the left side, in the bridge, it has got embedded sensors, IoT devices. They want the bridge to behave in a IoT-enabled smart manner. It means continuously they are collecting the data corresponding to how many people use the bridge, what is the temperature, is there any corrosion that's sitting on the bridge, what is the humidity level. So the bridges are becoming smart and giving the data to the local administrators. And you look at the post office building which was created in 3D printing, using 3D printing by L&T in Bangalore. It was constructed from concept to realization, it was less than 30 days. So things of this kind are happening right here in our country. So the reason why the digital technologies are coming to the forefront in a big way is, in the olden days, come to the office, go to the office, do something, nobody used to bother. But most of the companies now, they talk about how efficient is the process, how profitable, what is the throughput, whether you are able to provide design freedom, whether you are able to do the mass personalization. These are all the criteria which companies are looking forward to realization, and that's why more and more digital practices are coming to the forefront. And you will be surprised today if a person goes for a knee replacement or a hip replacement in a hospital called Vedanta MedCity or Apollo. In the olden days, whether you are a tall person or a short person, you are a fat person or a slim person, the implants used to be made absolutely the same way, and the surgeons used to pick up a standard implant and get it fitted. But now, they take the data from the CT scan, use the data from the CT or X-ray to do the mass customization of the implant and create an implant using 3D printing out of titanium material and fit the mass customized, means customer specific implant to the person. So, too much of focus on the efficiency. If you were to look at the combat aircraft of 1960s and 2000, the combat aircraft of 2020 is much faster, much more reliable, much more agile compared to what it was about 40-50 years ago. But the size of that is half of what it used to be. I gave the example of Nexon car versus the Ambassador car. Nexon car is half the weight of Ambassador car, but you can drive faster. You don't require fossil fuels. The Nexon car is also connected. So more and more companies are moving towards bio-inspired solutions. For example, what you see on the right side is a design inspired by the human lungs. Human lungs are the best examples of heat transfer. So in this case, the heat exchanger of a system of a power installation has been redesigned to look like a biomimicking design, and fundamentally what they're interested is improving the thermal efficiencies of the breaker's supercritical carbon dioxide cycle by going for biomimicking heat transfer design, and which is made from cobalt chrome alloys using additive manufacturing. Next one please. If you look at the x-axis, it is density. If you look at the y-axis, Young's modulus. So top right means metallic materials. So they have high density means high weight. They have also got high strength. Now go to the bottom left. Bottom left, what does it indicate? Low density, low strength. That's why when you go to use rubber or polymer, the density or the weight is less, but the strength is low. What if you make the parts hollow and strong? So that is the portion on the top left. This particular diagram is called Ashby diagram. So now many parts are getting redesigned so that you can make them hollow and make them more efficient, make them less heavy. So what is additive manufacturing? It's not a single technology. It's many technologies. They are known by different names like orbit fusion, like stereolithography, like fuse deposition molding, layer manufacturing, binder jetting. So what is a common thing is all of them convert your CAD data into a physical part. Some may make it out of plastic material, some may make it out of composites, some other systems can make it out of metal. And where exactly use them? You can use them for developing new products, for optimizing the designs, for making the tools. So this is a symbolic representation. So polymers, waxes, composites, metallic materials, thermoplastics, resins, you can make the parts from different materials. So if you are talking about additive manufacturing today, I just want to tell you that additive manufacturing today is not a manufacturing technique. It's actually interplay of software engineering, finite element analysis, control systems, laser physics, polymer chemistry, quality, etc. And you can use this additive manufacturing as a technology for designing your mobile phones, for designing rocket engines, for designing the electrical vehicles, and for designing the medical devices. The applications are plentiful. Now, what is the principle? You start with a CAD model. A CAD modeling can be done, as I already told you, by a 4th standard student. So, never ever for a second, microsecond also imagine that computer science student cannot do, electronics student cannot do. I will demonstrate, I will be giving the names of the students who do CAD modeling while they are in the school. I will show you the photos also. Okay? And then take the data, give us the input and produce the parts. And once you make the part, you can use it for drone application, or you can use it for jewelry application, or you can use it for connecting with the maxillofacial, craniofacial, or accident victims who require a customized implant. In case of 3D printing, you don't use any tools. In case of conventional manufacturing on the top, you are creating a lot of waste which comes in the form of chips. Whereas in case of 3D printing on the bottom, you only put the material where you want to put it. So the top is called subtractive manufacturing and the bottom is called additive manufacturing. He wanted to start a company that makes 3D printers. When he started his company in Bangalore, he could not get good electronics engineers as employees. You know what he did? Why do I struggle in Bangalore trying to recruit good electronics engineers? He went to Taiwan and started his company. And the name of his company is Accurata. He has sold more than 10,000 3D printers sitting in Taiwan to all parts of the world, and he employs more than 25 Chinese electronics engineers. So that is the power of Indian engineers today. Forget about we using Chinese products. This fellow has gone to Taiwan to create a company in Taiwan, employing the Chinese electronics engineer and making the 3D printers and selling all around the world. So the students and the faculty of the current generation have to really think in a different manner. Okay, next. This is my example from, I went to Mumbai. This guy is from Jaipur. The entire statues, beautiful statues of Ganesh were made using recycled plastics. See, in the Atal Tikkari lab or Idea lab, you might have put 3D printers. You create lot of junk plastic. What do you do with it? You need to recycle them. If you don't recycle them, they create environmental menace. So this gentleman has created a 3D printer which takes waste plastic, recycled plastic, and converts them into these huge monolithic structures like the Ganeshi murtis which are used in the printers. So that is the power of innovation which is coming in the country today. Next. So if somebody is talking about 3D printing, just don't be under the impression that it's only some mechanical engineering companies. You get 3D printing in defense and aerospace, you get them in tool room, you get them. The biggest user of 3D printing in the country today is Tanishq. Because every season, Tanishq and Titan Jewelry release thousands of designs for Diwali, for New Year, for Christmas. So where do the designs come from? You don't have those old generation, craftsmen coming and sitting. So entire Tanishq jewelry which you see now, they are getting digitally designed. Okay. Next one. So how does this metal 3D printing work? Click on this. So to start with, you need to create a CAD model, and the CAD model is sliced, and the sliced data will go to the 3D printer using your intranet and internet. And you can see here a laser beam traverses on the powder bed, and wherever the laser beam is in touch with the powder, instantaneously the powder is melted, and what you get is transformation of the metal powder into physical part. The part could be made from titanium, aluminum, nickel, steel, cobalt chrome, tungsten, molybdenum. You can make any part using this kind of a technology called powder bed fusion. And if you are under the impression that this particular technology is there only in ISRO or DRDO, please change your opinion. There are more than 1400 Indian industries which are using these metal laser 3D printing systems. My conservative estimate of number of companies in Noida, in Delhi, about the usage of metal 3D printer will be close to 100. And these are operated only highly skilled students who know how to operate with the lasers and the powders. Yeah. It comes now. Okay, next. Okay. So you will be surprised to know that this entire technology didn't start in the industry. It actually started in University of Texas, Austin. And you can see here, the student name is Carl Decker. He started this project of 3D printing mission as his BS undergrad program. He was fascinated, 87 I think. Then he continued with his masters and PhD, and finally it led to the emergence of this 3D printing as an industry itself. So the birth of metal 3D printing was in a university. Next one. So this is how the industrial parts look like. The next one. And you'll be surprised now, lots of companies now in the automotive world have started additive manufacturing campuses. I'm just giving one example. BMW is one example which I'm giving. It could be Volvo, it could be Tata Motors, it could be Mahindra. What they are doing is they are maintaining a clutch of metal polymer composite 3D printing systems manned by only 4 or 5 people. And if you want any part to be made either for prototyping or a spare part, you don't have to go to the headquarters all the time. It is printed on site at the point of requirement and delivered within a couple of days. This is called just-in-time requirement. And they don't have to maintain thousands of spare parts in the inventory. They can only print it as required or depending upon the customer choice. Next one. So The one which used to be conventional like that on the top left for mechanical engineering, now it is becoming on the top bottom right. So unless you connect with the industrial practices of Industry 4.0, additive manufacturing, your impression of manufacturing will always be like that on the top. That used to be there in 10 years ago. Most of the companies today in the country have got these kind of shop floors. Next one. Next. Next, please. Next. Yeah. Yeah. Next. Yeah. Next. Okay, where are we in India? In India, in the recent times, there is tremendous amount of interest among the incubators, innovation centers, and startup community, campuses. I cannot be exaggerating if I say that at least some 30 plus incubators in the country, in different parts of the country, are designing, developing indigenous 3D printers. I am personally in touch with at least half of them in places like Manipal, IIT Madras, SRM University, VIT Gallu. And we are also making powders, we are also making the feed material, and the parts and systems created using additive manufacturing have gone to space missions, have gone to defense missions, and have gone to aerospace missions. So if anybody comes and asks the question like whether the part is good or not, strong or not, usable or not, they should only refer to the kind of development which has happened in the last about 30 to 14 years in the country. Okay? Next one. Now, this is a wonderful subject. If you look at the basic foundation of the subject, this is actually closer view of what happens in case of powder bed fusion. The energy is coming from the laser beam into the powder particle, and instantaneously the particles are getting melted. The heat from the molten pool is given away to the substrate because of the conduction, and since there is a small differentiation in the surface tension within the melt pool, it gives rise to convection. It is called Marangoni convection. So there is a continuous bubbling in the melt pool. And we also use the process chamber gases to drive away the emissions. So the situation there is reminiscent of conduction, convection, and radiation. And melt pool, incidentally, depends on the surface tension and inertial forces, not on the gravity forces. That's why many NASA missions today are carrying the 3D printers, and in space they are producing the spare parts for the long haul space missions. They don't want to carry tens of thousands of spare parts. Imagine that there is a space mission which lasts for 6 months, 9 months. Where can you make the spare parts? You can't carry all the spare parts. If you carry all the spare parts, there will be a big penalty which you need to pay. So they are carrying 3D printers for in-space printing. Next one. Next. Okay, so I'll come to the final conclusion portion. I'll go there. So I think I need to cover a very important portion why this skilling as a subject needs to be taken up at JSS. Okay, first I will talk about what you can look forward to sitting in a place like mine. The Government of India has announced, why don't you just leave it? I want it that way only. Government of India has cleared recently something called National Research Foundation with a budget of 15,000 crores. The first year itself they are releasing 40,000 crores, and the funding is for translation research, not only the basic research. You could be an academia, you could be a private industry, you could be a private university, or you could be a R&D lab. You can connect with each other and submit the proposals, and you will be surprised, DRDO itself has come out with 800 different problem statements in their document called DRDO Academia Partnership, which was released in May 2023. And what does it say? What are all the problems in which a faculty member can conceive or conceptualize a project proposal and submit it for the funding by Day1. So I'll just give an example of how a computer science faculty worked with the mechanical engineering faculty and got about 40 plus lakh funding and Day1. So there is one chemical called thermal paint. What does that thermal paint do is, if you spray the paint on the surface of a component, if the component is subjected to the operation, depending upon the temperature of the component, the color of the paint changes. So look at the changed color, you can attribute it to the temperature. So this is a turbine blade, and you can see here, this is a butterfly coupler, and paint is put on one side. Actually, this is subjected to heating through passage of the current. You know, from the fundamentals of physics, you know, the heating depends on I square R, and resistance actually keeps increasing. So at the throat, you have got the maximum temperature when you send the current. So max temperature happens at the throat and less temperature on either side. And there are different colors corresponding to different temperatures. So in this case, what the team came out is, can a group of computer science faculty members who have got interest in image processing work with faculty members of mechanical engineering and develop an algorithm for looking at the data and convert the color plots into temperature plots. These are called isothermal plots. So if you see, it has got a fantastic practical application. Imagine you have got an exhaust section of a car or a bike or aircraft. How do you know what temperature it is subjected to? These things can be formed using these thermal paints. And the more and more cases of 3D printing are coming to the forefront in terms of connecting them to the 3D scanning. You make a part, you are not sure whether the surface finish is good, whether there is any excessive porosity, whether there is any distortion. So what typically people are doing now is, after making the part using non-contact scanning or contact scanning, we get the data corresponding to the surface finish and the porosities, the distortions. So you get the data corresponding to mesoscales, microscales, and macro scales, and do the necessary post-processing on the manufactured part so that it is useful. That's the reason why 3D printed parts are used in the medical application. Otherwise, it couldn't have been possible. So this is one of the ubiquitous 3D printers. As I told you, this just costs about 20 to 30,000 rupees, and it comes in different forms like Cartesian or polar or robotic 3D printing. Essentially, if you want a robo, put a 3D printing head, you can convert a robo into a 3D printer. That's what is done in the third case. So lots of people who are connected with robotics are coming into the 3D printing, and I have done lots of work on recycling of the plastic waste, because what happens is, in case of Idea Labs, you create a lot of waste. What do you do with the waste? Or if you have got a big campus, lots of plastic waste can be generated because of the packages or because of the Pepsi Coke bottles. So can you recycle them and convert them into filaments? Can you use that filaments back into 3D printer? This is one of the very important things. I think some of you would be knowing the sustainability development goal and circular economy. So many Idea Labs in the country today have started working on sustainability development goals by recycling the filaments. Okay, this is the part which I made for combustion studies while I was working as a GBRE. I'll just show one example and then I'll close my presentation. This was connected with the missile project. Canon launched the missile. The missile was launched from the Canon. And if you are teaching the design principles, 3D printing can also deal with polymer materials. For example, you have got a curved beam. Make a curved beam, put it in a polariscope, subject it to the loading. It develops the tensile, compression stresses, neutral axis, which you can see in the polariscope. Similarly, KFT. So you can teach the fundamentals of design, fundamentals of stress concentration, etc. Lots of case studies on the medical. This is a student from MS Ramaya who did a custom implant of a cancer-affected hip replacement surgery. Different concepts we developed for the customized cancer patient. And this is one which I got to see in Taiwan. wherein a mobile phone can be converted into 3D printer so that the screen of a mobile phone itself can work like a VAT. This is the one which happened to see in Germany during my trip to Formnext. So how to make large parts which are used in ships, submarines, or satellite structures, etc. So there, the principle is called direct energy deposition. You are delivering the powder. As the powder is getting delivered, there is a laser beam which is curing the powder in situ. Actually, the deposition head remains stationary. You can see there. Only the platform on which the part is getting built, it will change its direction. You can see there. The platform on which the part is getting built changes the direction, and hence you are able to make these extremely difficult parts out of steels and titaniums and nickels and cobalt alloys, etc., directly from the powders. So entire articulation is in the platform. Okay. So I think I need to stop this. I'll go to the concluding session. Now, Industry 4.2. So we are all very familiar that in Industry 4.2 we are talking about cyber physical systems. So the moment you are talking about cyber physical systems and data generation, we are not actually looking at one single technology. We are looking at IoT, we are looking at 3D printing, we are looking at cognitive computing, we are talking about machine-to-machine connectivity, interfacing, etc. And how this particular thing is impacting the industry is you get tremendous amount of data at sub-second level also. See, fundamentally because of the sensors which are prevalent in the ground and actuators, you are getting the data continuously. Then on top of that, you have got PLCs, then you have got supervisory level systems, you have got MES, and finally ERPs. Now, if you want to work in Industry 4.0 environment in the industry, you don't have to be a great coder. Either you can be no coder or low coder. What industry wants is, how do you understand the process in such a way that you are able to take the data from sensors, actuators, PLCs, SCADA systems to make entire process more efficient. So there is so much of focus on the coding. Actually, the coding is a very, very secondary aspect of what happens in Industry 4.0. So the terminology now is low-code platforms. In fact, current generation platforms, they say no-code platforms. So that is how the entire world is moving in terms of this is a very important thing. This is a thing which happened on 5th January 2023. Satya Nadella made a presentation in Bangalore for academicians. About 1,000 academic representatives gave to the program. January 2023, they talked about ChatGPT and DALI-O, etc. So we never imagined that within 6 months of this talking, the ChatGPT and generative AI will become such a common thing. Nobody imagined. When I attended this presentation on 5th January, I never felt that in 7-8 months down the line, everyone in the world would know about ChatGPT. So the message which I want to give is, people should learn the new technologies and new trends. This is the school student. His name is Prajwal. He is in BGS National Public School in Bangalore. He is in the 9th or 10th standard. This fellow has finished 11 certifications from Python, Scrum, Azure Administration, so many things connected with the data and AML while he is in the 9th standard. So, many times people ask the questions like, I am from electronics, can I do this? I am from computer science, can I do that? I am from mechanical. This is the answer. And he is not an exception. You will see that if you go to this particular platform, if you go, you will see thousands of school students who do AML programs. Thousands. And thousands of school students today, they talk about 3D printing. So, the final slide is, I have given this kind of lectures about 7 to 8 universities in Atal FDP program in the year 22. Currently, about 11,000 students are registered under a program. In fact, the program is called NILIT program. NILIT stands for National Institute of Electronics and Information Technology. Okay? What do they do? They have a program for future skills, and which they run the program along with CDAC and NASCAM. Very simple program. They have 14 verticals connected with AML, 3D printing, CAD, cyber security, data sciences, and the fee for that used to be 4,000 rupees. Now, if somebody has got an Aadhaar card number, if a student registers, instantaneously gets 90% discount. It means 4,000 becomes 400 rupees. So he registers for the program and he can download the data corresponding to 3D printing, and there is a node, there is a hub, there is a spoke. You can connect with one of the companies like EOS. For example, EOS is one of the biggest 3D printing companies in India, which is connected with ISRO and DRDO and all the automotive companies. You can connect with the NILIT, Calicut, you can connect with the EOS, Bangalore, and say that I want to be the student who want to understand 3D printing. So you become a student, you can download the material, you can read. After completing this course, you get a course completion certificate from Ministry of Electronics, and you also get your ranking, you got a QR code which is linked to your CV or LinkedIn profile, etc. And last but not the least, you don't have to write any exam. Absolutely no. They just want you to attend all the sessions carefully and make sure that at the end of the program you get this kind of a certificate. So I feel really it's very, very important when we talk about skills. It's not about some training sessions like this. We really need to connect with the industry requirements. We need to connect with the certification possibilities and get your skills in such a way that they are relevant to the world. So my final slide is this. I think you people keep saying every day, Apple wants to make 1 lakh phones per day in India. How do they make? Where is the plant coming? It's coming near Chennai, it's coming near Bangalore. They want to set up so many plants. They have recruited 20,000 plus engineers recently, along with Tata Electronics. Where do you think these engineers are coming from? Do they come from China? Or do they come from Russia? Do they come from Ukraine? No, they're all coming from India. Who are those students? The students who understand Industry 4.0. The students who understand automation. The students who understand how to combine the skills connected with the digital technologies and make it useful for the industry who is the primary user. So whenever you see this kind of a news item, you can clearly see that when there is a news item of this kind, there is somebody like you who is likely to work in the job. And the difference between you and him or her is a skill. And that is a skill which you need to gain using this program. Thank you very much.
Thank you so much. So, have you enjoyed the session?
Yes, ma'am.
Yes, it was really a great learning for all of us. And teaching is the highest form of learning. And researchers and researches, they are manifestation. And through this learning, I think I am very proud to be the part of this workshop because I have learned many, many things and few eye-opening things that sir discussed. And the important point that was very eye-catching and eye-treat was digitalization or enterprises or ONDC. I would say that's the Open Network Digital Commerce. I think that's a really, really great platform which every one of us should work on it and should get registered by ourselves. Anyways, thank you very much, sir. You spoke about each and every topic in such a judicious manner, in such a stipulated time allotted to us. And for concluding remarks, I would just call Professor Sampath sir just to make a concluding remark.
So indeed, it is one of the wonderful sessions. I always, whenever I attend sir presentation, it's like you get not only Industry 4.0 skills, you get Industry 4.0 energy. I hope you all have got some special energy and motivation irrespective of the background. That was the highlight of this session, that he was insisting it is no more only coding platforms. Nowadays, it is popular. You see all your employer requirement is non-coding platforms with industry 4.4 skill set. Hence, whoever is there here, student representative and Ideal App ambassadors, kindly pass on this very important message, and also you try, we will also try to spread whatever sir has shown here, and also we will share important slides of this presentation with permission of sir to all the stakeholders of JSS80 Noida. When we invite next time, at least we should be in a position, few of our students should be registered under ONDC platform, and we should say which statistics so many of our department or institution students who are enrolled for digital entrepreneurs. And also, very important platform, the future skills initiated by MIT and NASCOM, and we have MOU with NASCOM and same program for us. It is same. If you have JSS ID, they will get 90% discount apart from whatever you have. If you want only participation certificate, it is well and good. One of the good highlight of the future skill program is more than 2,000 startup companies, they are going to see your skill development. They will observe, and depending upon their requirement, they will get in touch with you for recruitment. That is the beauty of this ecosystem what they have initiated. And we are very fortunate in 2019, myself and former principal Dr. G.M. Patil, when they have launched this future skilling program in New Delhi Lee Meridian Hotel, we were part of that program. That's why the Ministry of Education and mighty MSME ministry, they have inaugurated this program in association with CDAC Noida. So, overall, definitely, we thank you, sir, and I have been telling my colleagues, after listening to sir, you all will get different kind of inertia. I am sure you all have obtained that. Thank you very much.